Welcome to this tutorial on implementing data deduplication techniques in Java. Today, we'll dive deep into the concept of data deduplication, its importance, and how to effectively implement it using Java. What is data deduplication? Simply put, it's a process used to eliminate duplicate copies of data in a dataset. It is especially critical in areas such as database management, storage optimization, and data analysis. Why is deduplication important? Data duplication can lead to increased storage costs, inefficient data processing, and incorrect analysis results. Hence, implementing effective deduplication techniques can enhance performance and reduce costs. In this tutorial, we will cover various techniques for data deduplication using Java, including using sets, maps, and more advanced algorithms like fingerprinting. We'll also explore real-world scenarios where deduplication can be applied. Let's start with the simplest method, using a set in Java. A set inherently prevents duplicate entries. Here's how you can utilize it. In this code, we create an array of strings that contains duplicates. We then create a hash set, loop through our array, and add each item to the set. The hash set automatically filters out duplicates for us. Next, let's look at using a map for more complex data structures. When you need to retain associations between keys and values, a map is very useful. We'll implement this with objects to demonstrate effective deduplication. In this example, we define a product class. Then using a hash map, we loop through an array of product instances, selecting only one instance per unique product name. This way, the last product that is added will overwrite any previous entries, achieving deduplication. Let's move on to a more advanced technique known as fingerprinting. Fingerprinting can help identify duplicate records that do not match exactly. One common algorithm is the min-hash algorithm. We'll focus on a simple implementation here. Here, we implement a basic min-hash-like approach using jacket index to calculate the similarity between two sets of data. The closer this value is to 1, the more similar the data sets are. In practical applications, you would use more rigorous hashing techniques to achieve more reliable results. Now, let's discuss a real-world application of these techniques: cloud storage. In cloud services, avoiding duplicate data can considerably reduce the amount of storage space required. Let's imagine you're working on a cloud storage application. At upload, you could implement a deduplication technique to check if the data, like images or documents, already exists in storage before saving a new copy. Here's how you could approach this. In this cloud storage simulation, we check if the file is already present before uploading it. If it exists, we skip the upload. This simple technique ensures we save storage space and improve data consistency. Next, we can explore another practical scenario: data integration from multiple sources. When merging datasets, it's common to encounter duplicates. Let's create a deduplication process for integrating customer data from various sources. In our customer data integration example, we've created two sources of customer data and used a hash set to merge them while eliminating duplicates based on unique email addresses. This method can be extremely useful in scenarios where customer data is acquired from different systems or third-party services. Now, let's summarize some best practices for implementing deduplication in your applications. 1. Always use the appropriate data structure. For example, use sets for simple deduplication and maps when you need key-value pairs. 2. Consider using hash functions for larger datasets or when working with non-trivial data. This aids in achieving faster deduplication. 3. Analyze the context. Deduplication methods vary greatly depending on the type of data and the application requirements. 4. Test the performance impact of your deduplication processes, especially in high-load environments. You want a balance between data integrity and performance. 5. Log and monitor deduplication actions, especially in business-critical applications. With that, we have covered the essential aspects of data deduplication in Java. We've explored practical implementations, techniques, and considerations for real-world applications. Thank you for watching. If you found this tutorial helpful, please give it a thumbs up and subscribe for more Java tutorials in the future. Let us know in the comments which technique you found most interesting and any other topics you'd like us to cover.